Hello there, our wonderful and respectable viewers on this favorite mathematics channel, Mathematics by Abu Zainab. That special YouTube channel created for you and I to come together to demystify mathematics and tackle the age-long phobia associated with this all-important subject, one topic at a time. Today promises to be another interesting episode in our series of topic, sequence, and series. In the past videos, we looked at the concept of sequence and series and various types of sequence and series that exist. And of importance are restrictions to just AP and GP for secondary school level. In the previous videos, we have completely looked at the concept of arithmetic progression, popularly called AP. Today, we are resuming with the counterpart of AP, which is geometric progression, popularly called GP, or exponential sequence. Today, we shall be learning the end term of a GP, the formula for end term of a GP, and of course, look at classic examples of problems on geometric progression. So I enjoy you to ride along as we enjoy mathematics. Thank you. So today, we're looking at first end term of a GP. Just like we had for the AP, the end term of a GP has a formula and is given as Tn equals to A R raised power n minus 1. So we need to define what each of these parameters stand for. So Tn is simply notation for the nth term, or in some cases is referred to as the last term. A is our first term in the sequence, and R is the common ratio, whereas n is the number of terms in the sequence. So these are the basic concepts we'll be looking at in the formula for end term of a GP. So let's have a classic illustration of what each of these represents. Let's say we want and have 4, 12, 36, on like that. And here we have 144, 72, 36, and let's say 18. So let's look at these two classic examples of GP and use them to explain the concept of the parameter. So to start with here, A, as we said, is the first term. So the first term here is 4. So we have here 4. And then A here is also first term, which is 1, 4, 4. Which are the terms. Then the next common ratio here is R. R is common ratio. Now, just like in AP, whereby we have that the common difference is the second term minus the first term, and that corresponds to the third term and the second term. Similarly here, we're going to have this time around second term divided by first term instead of subtraction is a ratio, or third term divided by second term. So if these divisions or ratios are equal, we call these then the common ratios. In this case, 12 over 4 is 3, 36 over 12 is also 3, and the common ratio is 3. Please take note again, the common ratio is taken backward, just like in your GP. That is, second term divided by first term, third term divided by second term, and so on and so forth. So not forward but backwards. Similarly here, the common ratio is going to become 72 over 144, then 36 over 72, and then we have half in that case. So that has to be a common ratio. Now, the next concept is n. N stands for what? The number of terms in the GP. So how many number of terms we have here? We have 1, 2, 3. We don't know how many indefinitely, so you have unknown number. It's not set in there. Whereas here, n is simply 1, 2, 3, 4. Because it's a full stop, that means that's period, that's all. So decisively, n is 4. We have 4 terms there. Then lastly, Tn, which stands for what? The last term or end term. So again here, we don't have the last term because we don't know for certain what the last term is going to be. So we also have the question mark. Whereas here, our last term is obviously 18 because there's a full stop. That's the last. So these are the explanations for the various parameters we have in the formula for the M term of a GP, which I believe we found quite straightforward. So let's dive along by taking our very first example proper. So let's add our first example here, 1. So find the 8th nth and n plus 3 10 of the sequence, and we have here 1/2, comma, minus 1/4, comma, 1/8, comma, and so on. Okay. Here we have to find the 8th term, the nth term, and n plus 3 term of the given sequence. As I've always emphasized in the previous videos on sequence and series, that it's not necessarily every time you have the grace of being told what the sequence is. So if you are having such a situation, all you need to do is to first test to find out what the sequence is. Now, I made it known copiously in a few previous videos that to know an AP, you carry out the subtraction technique. That's a common difference. If the second term and the first term equals the third term and the second term, that is common difference, and that sequence is an AP. Here, however, we test by division. That's how GP works. So here, before you decide that this is an AP or GP, so minus quarter over 2. Likewise, 1/8 over minus quarter. In each case, the answer is minus half. Hence, we have a common ratio of minus half. So the parameters A is half, R, which is minus quarter, divided by minus half. And that gives minus quarter times 2/1, which is minus 1/2. Similarly, 1/8 divided by minus quarter still gives minus 1/2. Hence is a GP because we have a common ratio. After listing these two parameters, you can now go ahead and find our 8th term. Now, so in formula we have Tn, which is n term. In other words, to find 8th term, just replace the n in the formula with 8. So I'm going to say T8 equals to AR. Then 8 minus 1 is 7. That's AR 7. And after that, we slot in our values. A is half, and R is minus half. So we have minus half raised to power 7. And that's your answer. That's the answer. Normally, we should be able to use the law of indices here. But because of this technicality of time minus here, we can't easily apply. Because remember, in our video for indices, we have x power a times x power b. We are simply going to say x power a plus b. Of course, we are presuming n at the same thing really. But half and minus half are not the same really. So you can't easily use that rule here. We can't. However, we can do something. We can see this half. We have this actually half times minus 1 raised to power 7. So that's going to become half. Then half power 7 minus 1 power 7 as well. So we can now apply that law readily here because we have half and half as the same thing. And this power 1 here, of course, so that's half power 8. And minus 1 power 7 is still minus 1. So we can now actually simply minus half power 8. That's the answer. Note, if you put the minus in the bracket here, very technical, you put minus in bracket here, this even power is nullified to make it plus. So that's the caveat here. So you can't show that. So it's going to be minus times half power 8. That is very, very technical really. Because if you use a power and even number power, you can't have negative any number. So that's the more reason the minus has to be outside the bracket and not inside the bracket. And that's that about that. That's number 1. Number 2, we have to find the nth term now. So for nth term, for the nth term, n remains n in the formula. So you have Tn equals AR power n minus 1. A being half, and r being minus r. So we have minus r raised to power n minus 1. So avoid any technicalities here, we leave that as the answer. That's r times minus r raised to power n minus 1. Note again that if they are the same, maybe minus here as well, or they are both positive, you can easily apply the law of indices. Then the last one then, number 3, which is the n plus 3, and that's t n plus 3. Again, n plus 3 replaces n in the formula. So you have AR, note, there's n in the formula here, so to become n plus 3. Then the existing minus 1. So hence we have ARn plus 2, because 3 minus 1 is 2. Then substituting the values of A and R, A is this, R is that, n plus 2. And that again is the answer to that particular question. So with that, we have come to the end of example 1. So let's take example 2 to see how it plays out. So for number 2, the question this time around is that how many times are there in the sequence 1, 2, 4, then 20, 48. How many times are there in this sequence? Once again, without wasting time, let's verify it is equal to GP. So 2 minus 1 is 1, 4 minus 2 is 2. The fact that the subtractions are not the same, that's not a common difference. And that nullifies the fact that this can be an AP. So we tried the GP method, which is division. So 2 divided by 1 is 2, 4 divided by 2 is also 2. Automatically it's a GP, with A being 1 and R being 2. So we are, however, what's n here? We don't know, that's the question. How many terms? We don't know n. But what is our Tn, the last term? 20.8. So after you see parameters, then go ahead and just simplify. So recall that Tn equals to what? AR power n minus 1. So Tn is 20.8. A is 1 and R is 2 raised to power n minus 1. Of course, 1 times everything is still out there. So we have 20.48 equals to power n minus 1. And this takes us back to indices, initial equations or exponential equations, which we have treated in our previous videos. So to express in terms of the same base, this will become 2 to the power of 11. Because 2 to the power 11 is 20.8. So you have 2 raised to power n minus 1. And we have the same base. We simply equate the index, which is n minus 1, equals to 11. Then n is equals to 11 plus 1. Therefore, n is 12 in conclusion. And that is the solution. That means there are 12 times from 1 up to 2.8 at the ratio of 2. And that's will come to the end of the lesson today, which promises to be as fun as I think it is there. So if you find today's class very interesting, do well to stay tuned to our next lesson, which shall be proper using of n term of a GP. This is basically the introductory aspect of it. Thank you and stay blessed.